having a negligible resistance is connected to a 1.5 times 10⁻³ hertz. You are given the frequency 1.5 times 10⁻³ hertz. That is the value for frequency. What is the inductive reactance? Inductive reactance is 2πfL, which is 2π. Our F is 1.5 times 10⁻³. Our L is 12 times 10⁻⁻3. This goes, it cancels this. Then we can easily calculate the remaining values. Let's see what will be the value of 2 times 1.5, then at the same time times 12. This is 36. 2 times this will give us 36 pi. 36 pi, and we can 3.142. If we want to calculate everything together, times 3.142 will give us 113.112, and simply 113.1 ohms. And that is a simple solution to that question. Question number 9. A capacitor of capacitance C, the value for the capacitor is 2 microfarad, which is 2 times 10⁻⁻6 farad. Having negligible resistance is connected to a 1.2, that is the frequency, times 10⁻³ hertz. Okay? What is the capacitive reactance? Xc. You remember that the formula for capacitive reactance is equal to 1 divided by 2 pi Fc, which is equal to 1 divided by 2 pi F. 1.2 times 10⁻³ C. 2 times 10⁻⁻6. This is 1 divided by 2 pi 1.2 times 2, 1.2 times 2 together, then 10⁻³ 10⁻⁻6 will give us 10⁻⁻3, because 3 minus 6 will give us -3. Okay? And we can write it like this. Xc is equal to 1 divided by, this is equal to 1 times 10⁻⁻3. Why? By the time you take this one up, it will change from -3 to +3. So what we are going to have left is 2 pi times 1.2 times 2. Or we can take everything together. Let's take everything together. We are going to have 2 times 1.2 times 2. That's 4.8 pi. 4.8 pi. 4.8 pi. Which is equal to 10⁻³ divided by 4.8 pi. This is 1000. In terms of pi, or let's say this is 4.8 pi times 3.142, which is the value of a pi. 1000 divided by 4.8 times 3.142 will give us 15.0816. And if we divide it by 1000, we are going to have the value 15.0816 816. The value there is 66.305. Okay? You can say 66.31. And we are looking for capacitive reactance. What is the unit? Ohm. Ohm. Ohm is the unit. And that's a simple solution to that question. Now we want to move to another new topic. The topic is all about the equilibrium of forces and moments. Under this topic, the candidate should be able to analyze the principle of moment of a force. At the same time, the candidate should be able to determine moment of a force and couple. Candidates should also be able to describe some applications of moments of a force and couple. At the same time, the candidate should be able to apply the conditions for the equilibrium of rigid bodies, to solve problems. Then finally, the candidate should be able to resolve forces into two perpendicular directions, apply the condition for the equilibrium of coplanar forces to solve problems. We are starting with moments. As we can see, in summary, moments of a force about a point is the product of the force F and the perpendicular distance from the point to line of action of the force. The two things you should take note here: the product of the force F and the perpendicular distance. If you take note of this definition of moment, it has the same unit with that of work. When we have to define work, we say work is the product of force and distance. But in this case, it's perpendicular distance. And that one is telling us that moment is a vector quantity, while work is a scalar quantity. So from this definition, you can see that by the time we apply a force on a body and a distance is covered through the application of the force on that body, then we have a moment. But in this case, let's consider what are the examples of that. The opening of the door handle. You want to open the door and you are trying to turn the door handle. As you are turning the door handle, you apply a force on the handle. And by the time you apply the force, the distance of the door handle will be shifted from the previous place to another point. And that is moment. Okay? You also have the turning of the tap. The turning of the tap, riding bicycle, lever, bottle cap. So you may be told to give an example of a moment, or you may be given a algebraic question that goes with this one. These are the relevant examples. Then what are the conditions for coplanar parallel forces? Let's consider this diagram. This diagram is a critical case of a body. For example, you can take this body as a meter rule, a uniform meter rule, or a rod. That we have a forces acting on it. We have force A, force B, force C, or we can take it as a weight or masses. Okay? We see A, we have B, we have C, and the center, the weight of the body is being acting at the center. Okay? That is what we call the center of gravity. Okay, that is the center, the weight of this body is being concentrated at the center. Okay, so if we are to find the moments of this body now, what we have to do is this. We have what we call the principle of moments. The principle of moments states that the clockwise, okay, the principle of moments states that the clockwise moment will be equal to the anti-clockwise moment from a particular point, okay, and from that we can have from this diagram clockwise moments should be equal to anti-clockwise moments. If you look at the diagram, this is clockwise, this is anti-clockwise. For clockwise, we have the weight C, or it can be a mass that is being hung on this body. So it's going to be the mass or the weight times the distance to the point where we have the center of the body, or that sometimes we call it the pivot or the fulcrum. Okay, so we are going to have C, capital C, times small c is equal to, but if you look at the other side, where we have the anti-clockwise side, we have two masses or two weights hang on this body,